Year 10, Mr. Davidson here, and I'm going to take you through the flooding work that you've been set this week, so starting on Monday the 29th of June. So first things first, before you do anything, if you are in school this week, so that's Monday the 29th to Friday the 3rd, if you're in school this week, you do not need to do this work. You're going to do this work next week, and you'll be doing separate work in school. If you're in school last week, then you need to complete the work from last week. So instead of doing week 4, you need to do week 3. So one more time, if you're in school this week, do not do this work. If you were in school last week, do last week's work, that's week 3. If you don't fit those categories, so if you're not in school this week and you weren't in school last week, do this work. Okay, let's get started, shall we? So by this point in your rivers unit, you can now explain the different sections of a river, so the upper, middle and lower course. You can explain whether erosion, deposition or both is the dominant process in each part of the river. And you can also talk about some of the landforms and features in each part of the river. So for example, meanders in the middle course, estuaries and floodplains in the lower course, or waterfalls in the upper course. This week though, we're going to start looking at how and why rivers flood. So some of you might remember we did do something similar in year 8, but we're going to deepen that knowledge by the end of this week. So by the end of this week, you'll be able to explain what flooding is, some different factors that increase the risk of floods happening, and also how we measure rivers during a flood. So let's go through some of the activities this week, and hopefully I'll be able to explain some of the trickier bits for you. So first things first, you need to explain the difference between a river flood and flood risk. I would suggest looking at page 124, which I've got open here on the right of the screen in the textbook, and that will help you with this. So it might sound really simple. What is a flood? Well, a flood is when a river bursts its banks. However, a flood is different from flood risk. So I guess the analogy I would make is the difference between falling over and the risk of falling over. So falling over is literally when I go backside over front and I land on the floor and I'm not having a very good time. The risk of me falling over is the chance of that thing happening. What's the risk? Is there a high risk, a high chance of me doing it, or a low risk, a low chance of me doing it? And I want you to explain the difference between those two terms. The next thing I want you to do, which is at the bottom of page 124, is to summarize some different human and physical factors that can increase the risk, the chance of a flood happening. Now you might also want to use Bite Size or Cool Geography or Seneca, because there are loads of resources for this on the internet, but they'll all say fairly similar things. I would like you to summarize at least 2 human factors and 2 physical factors. Now I don't just want you to write down the name of the factor and then copy this down, because that will not help you in the exam at the end of next year. What I want you to do instead is to pick 2 of each, read through them, and then summarize them and explain them in your own words. And when you're doing that, I don't just want you to say what it is, but I want you to specifically explain how does this factor increase the chance, the risk of a flood happening. So let's do one together. For example, I'm going to look here at precipitation, so rainfall. Now you might already be thinking, Mr. Davidson, that sounds really simple. Good, let's go through it together then. So precipitation is simply rainfall, or snow for example, or hail, but it's rainfall over an area. So how does precipitation, how does rainfall increase the chance of a flood happening? Well, I'm hoping that you'll be able to say something along the lines of, well, increased amount of rain falling out of the sky means that there's more water flowing into a river channel. A river channel can only move water so quickly. So if there's too much rain, too much water flowing into the river channel, the river's going to overflow, burst its banks and cause a flood. So that would be your basic way in to that question. So I'd like you to do that for at least 2 physical factors and 2 human factors. Once you've done that, you're going to get onto probably the trickiest bit of this week's work, which is something called a flood hydrograph. Now, a flood hydrograph is simply a graph that shows you the progression of a flood in a given river. So I'm just going to scroll over to page 125. I'm actually going to zoom in a bit on this graph. This is a flood hydrograph. So I'll explain the rest of the tasks in a minute, but I'm just going to spend a moment explaining what this graph shows us. So a flood hydrograph has got two key parts on it. It's got bars, this little bar graph, and it's got this red line, this line graph, and they're both on the same axes. So the blue bars show you the amount of precipitation, the amount of rainfall, and the red line shows you the discharge of the river. Now, discharge is how much water is flowing through a part of a river at a given time, and we measure this in something called cumex. That is meters cubed per second. You don't need to remember the specifics, you just need to remember that discharge measures how much water is flowing through a river. So high discharge means there's lots of water flowing through a river. A low discharge means there's not very much water flowing through a river. And you'll see along the bottom of this graph is time. So essentially this graph shows us all the rain that falls, so maybe during a rainstorm like we've been having in the UK and London over the past few days, and it shows us how long it takes this rainfall to have an impact on the amount of water flowing through a river. So I can see here that, let's say this time is measured in hours, that there was this peak of rainfall. That's when the most rain was falling in this drainage basin, and then there's this gap in time, this lag time between the highest rainfall and the highest amount of water flowing through the river. Now you might think, well, hold on a second, if the rain's falling on the river, why doesn't it instantly increase the amount of water in the river? That's a good question. You need to remember though that a drainage basin isn't just the river itself, it's all of the land around the river that essentially, if water falls in that land, it will drain slowly downhill into the river. Now think about it this way, the longer it takes the water from the rain to get into the river, the longer it's going to take for the discharge of the river to increase. So for example, let's say you had rain falling on a really heavily wooded, a really big forest with a river running through the middle of it. Now we know that those trees are going to suck up water, we know that the soil is going to suck up water, we know that the leaves of the trees might stop the water from hitting the ground. So all of that rain is going to take longer to get into the river, which means that it will take longer for this line, to increase. The lag time will be longer because it's literally, very literally, taking longer for the rain to get into the river. However, if I was in the middle of a city, loads of concrete, loads of drains, no soil to absorb the water, if I get a rainstorm falling down on this city and there's a river in the middle of it, the water's not going to be absorbed by plants, it's not going to be sucked up by the soil. Instead, it's going to run quickly over the concrete, it's going to go through the drains and the sewers, and it's very quickly going to reach the river. So instead of having a long distance, a long lag time between the highest rainfall and the highest amount of water flowing through the river, that will actually be a lot shorter. The rain will hit the ground, run across the concrete, and go into the river. So the distance between the highest rainfall and the highest discharge will be shorter, it will be smaller. And that's essentially what I would like you guys to explain. So in task 3, I want you to look at this graph on page 125, and I would like you to explain, what does this graph show? What's the bars and what is the line? And also, what do the axes measure? And once you've got that, I then want you to expand and extend your understanding. I would like you to look at these two flood hydrographs. And I can see that the red line in these two looks very different. Here it goes up very quickly. Here it goes up more slowly. And I would like you to pick some of these factors and explain, how does land use or soil or rainfall affect the shape? of a flood hydrograph. And again, BBC Bitesize is a great resource for this. Seneca is a great resource for this. They've got some good explainers. Alternatively, you can email me or your teacher if you need any help. Once you've done those things, all you've got left to do is complete the weekly quiz, which I'll put on Teams on Wednesday. So one quick recap. Explain the difference between river floods and flood risk. Summarise how human and physical factors can increase the risk of a flood. Describe this flood hydrograph and why the shape of it can change, and then complete your quiz. Oh, and there's also some research work there for you to build out around the River Thames and the River Severn. If you need any help, please give me an email. I look forward to seeing your work at the end of the week. Have a great day, Year 10.